All right. So, quick recap on what we were doing. We are looking at how to use a scientific calculator, not a graphing calculator, because a graphing calculator is more powerful and you don't need as much as this is with a graphing calculator. With a scientific calculator, you need to understand that when you use the inverse buttons, they will give you only one answer. And you need to be aware that when you're dealing with your trig functions, with certain very small exceptions to the rule, there are two angles with this entire roundabout circle who are answers to this equation, but your calculator is only going to give you one of them. And so what we learned was if we are dealing with inverse sine, inverse tangent, or inverse sines, or sines reciprocal. Who is sines reciprocal? Sines reciprocal. Cosecant. These three, if you push those buttons on your calculator, they're only going to give you one answer, and that one answer is going to be the right side of a circle. However, for quadrant 1, it is dealing with what you're used to, but quadrant 4 is not dealing with the angles you're used to dealing with. It is going backward from 0 to negative pi over 2. So know that with those three inverse functions, you will only get one answer, and it will only be the right side of your, quote, unit circle. The other three trig functions are cosine. So if you're using inverse cosine or inverse cotangent, or who is cosine's reciprocal function? Secant. So if you are using inverse cosine, inverse cotangent, or inverse secant, you're only dealing with the top half of the unit circle from 0 to pi. And don't spill your cocoa seek. Yeah, I don't know if that helps, but that is what your calculator is going to be giving you. When you are working with non-unit circle answers, you have to have a calculator to find it. When you are dealing with finding the sine of theta when it's equal to 2/3, your calculator is, your calculator is only going to find you one answer. That one answer that it will find you is somewhere from 0 to pi over 2 or backward from 0 to negative pi over 2. It will give you only one answer. I want to point out to you that the y-axis for a unit circle, this is y equals 0, this is y equals 1, this is y equals negative 1. If this number here is larger than 1, there is no solution. If it is a negative number and you're dealing with a negative number that is smaller than negative 1, so like -2, -3, anything on that end of -1 is no solution. This number has to be between -1 and +1 to get any answers. Now, let me tell you that if it is equal to 1 or -1, you only get one angle. on the entire circle. Those are your exceptions to the rules. And when you get 1 or -1, you're not using a calculator. Usually you're expected to know through the unit circle that pi over 2 is the angle for which the sine is equal to 1. And negative pi over 2 is the angle for which the sine is equal to a -1. You're only going to need a calculator if this number is between -1 and 1. And that will only give you, though, one of the answers for an entire circle. So I've got 2/3. And just to point out to you, if my sine is equal to 2/3, then it's taking me to a particular point with a y-coordinate of 2/3 when a terminal side of an angle crosses the unit circle at y-coordinate 2/3, that angle has a sine value of 2/3. Your calculator is going to give you this angle. What it's not going to give you is the angle on the other side of the unit circle. And you just need to be aware of that with a scientific calculator. Once your calculator gives you an answer, and you want to make sure you're in radian mode, if you put this into your calculator, you will get 0.73. Now, you are going to be allowed to use formulas for the test, so you don't have to memorize this, but I want you to see that if you get this angle, subtract that same amount from pi, and you will get its horizontal equivalent position. And so pi minus the answer that you get from your calculator will give you the other point within a cycle who has that same answer to sine. And the reason I'm having you find two angles between 0 and 2 pi is because once you find the two places on the circle, all you have to do is add or subtract 2 pi any number of times to find every single possible answer to that equation. So we did that problem, and pi minus 0.73 got us 2.41. Both of those are positive numbers that are less than 2 pi. And let's just keep in mind, what is 2 pi? If pi is 3.14, 2 pi is 6.28. So just realize that you're getting two decimal numbers between 0 and 6.28. That's your goal. Now, we didn't do problem number 2 yesterday, so I'm going to start that now. This time you're looking at the value of your sine as a negative number. The problem we just did looked at when the sine was equal to a positive number. The thing that's nice about the positive number is it lands you in quadrant 1. If I'm dealing with sine, I want to repeat that my calculator will only give me a number that is from 0 to negative pi over 2 or somewhere from 0 to pi over 2. Since sine represents y values, and I know that this y value is -1, I know this y value is 1, I know this y value is 0, And I know some of those other special numbers. Negative 0.9 is, say, about down here. And that lands you in quadrant 4. Your calculator is going to give you an answer that is in quadrant 4. However, it's not going to give you 3 pi over 2 to 2 pi. It's going to give you the negative angle. So we're going to look at what we get with our calculator when we do inverse sine for negative 0.9. I'm going to open up Desmos. And if you're using Desmos, then you go over to functions, trig functions, and you have your inverse. If you're using a scientific calculator, make sure you are in radian mode, not degree mode, but radian mode. And every scientific calculator has buttons for inverse sine, inverse tangent, and inverse cosine. And that's why those are the only 3 that I'm doing. And then negative 0.9. And I'm getting a negative angle, negative 1.12. Come on. There we go. Come on. We can do this. We can do this, pen. One more week. That's all I'm asking. I believe that was what I just said. Negative 1.12. Okay. So understand what that's telling you is if you start at angle 0 and you go backward negative 1.12 radians, you'll be located here. And there is a, shall we say, silent partner on the other side that your calculator won't tell you about. And what I want you to see is that if you start at pi and you add this much angle, realize that this angle turn is the same as this angle turn. I'm just not drawing the best picture in the world. Adding this much to pi is the same as subtracting negative. So I want you to be aware that the formula does not change. If you are using inverse sine, pi minus the answer to your calculator will give you that second angle. That formula works 100% of the time where this is the answer to your calculator. Or from calculator. There we go. That will give you the angle that your scientific calculator will not tell you about. Now, due to the technicality of the directions, let me find this and then I'll get back to the technicality of the directions. I'm going to do pi minus that number. So I'm going to come over here. I'm actually going to put in pi minus, and 4.26 is what I get. Now, this radian measure is a solution to this equation. This radian measure is another solution to this equation. However, you're being asked technically in the directions to find two angles in between 0 and 2 pi. This one is an angle between 0 and 2 pi. This one is not. So how do I take this negative angle and find its coterminal version that is positive? How do I find a coterminal angle? Ah, thank you. Yes. Add 2 pi. So my calculator gave me this negative angle, and I'm requesting through these instructions for you to find the two angles when you make your first round in your positive angles around that unit circle. I've got the negative version of this position, and I have this angle. So if I take this negative angle and I add 2 pi to that, that will cause me to go around in the positive direction once and land me in that same spot. And that way you can say these are the two angles with a first round through this cycle, with a 0 to 2 pi first round, that are the solutions. And so I'm going to take this number and I'm going to add 2 pi. And that's going to find me the other answer. And this is just technically the way the problem is being asked. So 5.16. And now I can say that the two angles that solve, the only two angles that solve this equation, where those angles are between 0 and 2 pi, a positive one round around the circle, are these two. 4.26 radians and 5.16 radians. Now I'm throwing these negative ones at you so that you have some understanding of how all of this trig works with calculators. On the test, I'm not going to throw at you the negative issues, but for homework I will. For the test, I'm going to stick to finding the two angles with sine or cosine or tangent being equal to only positive numbers. All right, now I'm going to re-talk about number 3. I had done it yesterday, but I was trying to just rush and we were out of time. So I'm going to re-talk through it. When I'm dealing with inverse cosine, it is a function. There's only one answer that the calculator is going to give. Cosine will only give an answer from 0 to pi. Now cosine represents x coordinates as you go around a circle. My x coordinates are 1, -1, 0, and then I've got some special numbers that you're expected to know without a calculator around. 0.37 is a number between 0 and 1. I'm going to estimate about there-ish. And on this circle, the only angle who has a terminal side through that specific point is initial side, terminal side, whatever this turn is. That is what my calculator is going to tell me. So I'm going to go over to Desmos to see what that calculator tells me is inverse cosine of 0.37. And I get 1.19 is the radian measure. And that is this spot right here. Now, if I'm dealing with cosine, I'm dealing with all the way around the circle. When do I have an x equal to 0.37? On the other side of the circle, what the calculator will not give you, that is also an answer to the equation of cosine theta equals 0.37. If I want to look at what this angle is, then I'm looking at the symmetry of that angle is the same as this backward angle. If I start at 2 pi and I subtract the answer that my calculator gives me, that will allow me to locate the other circular position whose cosine is 0.37. Now I imagine with how technology is making life easier and easier, there may soon be a point where you don't need to go this intensely into your trig. But I will tell you this, the more intensely you go inside trig, the more you're going to understand it. And the technology does allow us to do things more accurately, but if we depend on it too much, we don't learn the deeper understandings of the math, which for some people they're perfectly fine with. But just know that if you want to understand better what's going on, you need to dig this deep to understand the trigonometry. Anyway, blah, 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 blah. So this is the theta that my calculator gives me. 2 pi minus that angle will give me, will give me the angle that starts here and goes around and ends there. So it's 2 pi minus 2 pi minus. And now it's 5.09. The answer I got from the calculator was a positive number. That gave me this angle. The angle that I just got using this formula, which is the formula I'm always going to use with cosine, got me my second angle. So let me make sure you're clear. I'm going to draw a circle, and I'm going to emphasize two angles that have that same x-coordinate spot. The two angles I just found were positive 1.19 radians and positive 5.09 radians. And then if I take those two numbers and I add 2 pi or subtract 2 pi any number of times, I will find every single possible answer to that equation. So my final answers are, if my pen will reload, there we go, 1.19 and 5.09 radians. And that's number 3 done. Number 4, we have cosine theta equaling -1/5. The inverse function will only look at 0 to pi. Cosine represents x. And I'm going to point out x coordinate 1, x coordinate -1, x coordinate 0. -1/5 is going to be about here-ish. So when I ask my calculator what is the inverse cosine of -1/5, the answer it is going to give me is the angle that begins at 0 and has a terminal side here. And it will be giving me a positive angle. And that's why we like cosine. So, calculator, inverse cosine of -1/5. And make sure that you know how your calculator works with inputting. Different scientific calculators have different orders of putting things in. You should be getting 1.37. But there is still an angle that my calculator, my scientific calculator anyway, will not find for me. And that is the angle, the second angle on a full circle that has that x coordinate. And I want us to look at the symmetry here. And I want you to see that this angle is the same measurement as this angle, but backward. So if I start at 2 pi and I subtract the angle my calculator just gave me, I will find cosine's partner angle. Bottom line, cosine always uses the formula 2 pi minus what the calculator gives you. For sine, the formula is pi minus the angle the calculator gives you. And those two formulas will allow you to find the second angle that the scientific calculator will not give you. Although I do see in the near future that we may not need this because the graphing calculators are powerful enough to not have to go this far. But with the scientific calculator, which is still considered the calculator, the standard calculator that you would be expected to use on a test at this level of math. And I don't know how things are going to change with technology. I do anticipate that fairly soon we won't go this deep into the trig anymore, and we'll just use graphing calculators all the time.
Also, I think in the answers, I remember doing this when I got a different answer than I was in the lesson. So I believe you wrote 7 instead of 1.77 instead of 1.37.
That is quite possible. You're talking about number 3 here?
4.
Oh, number 4. Okay. Let me see. So I have 1.772 written. Oh, I didn't put my negative in. Well, I'm a goofball, aren't I?
Well, I think you saw a negative 1/5 in there.
1.77. Let me double check. Okay, I've got 3 digits after the decimal point on that one. But right now I'm just doing 2 digits. 1.77 is supposed to be the answer I got. I did not put my negative in my calculator.
Oh my God, look at that.
Yeah. That was a negative 1/5.
Yeah, I put in 0.2.
Yeah. Yeah, that's the forgetting of the negative number. So I had to put that in and that changed it. And then the second angle is found by doing 2 pi minus that. So 2 pi minus, and 4.51 is the other angle. So that gives me an answer of 2 radian measure angles that solve this equation. And if you needed to find any other, you would just add 2 pi. Okay, so that's your sine and your cosine. Those are done. Tangent has something beautiful. Whatever your calculator gives you, if you add pi, you will get your second angle. So this goes back to what we already, come on, what we already know. I know the battery is just about out on this pen and I can't change it because I can't pull the old battery out. I tried and it's stuck inside this tiny little tube. It's fantastic. Ugh. With tangent, always, 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 no matter what angle you land on, the other angle is halfway around the circle every time. So that creates a more convenient formula. Now I'm going to write down the formulas to find the other angles that your scientific calculator will not tell you. If you're dealing with sine or inverse sine, then it's only pi minus the angle your calculator gives you. Scientific calculator. If you are doing inverse cosine, 2 pi minus whatever angle your scientific calculator gives you. For tangent, it is flat out going to be every single time that angle plus pi. And this formula, I want to point out again, this inverse tangent formula is one that we actually knew before this point, because that's how we've been finding our inverse tangents, or our tangent partner pairs. Okay, now we have 2 last examples to finish this particular classwork. I'm going to erase some of this business up here to kind of lessen what we're looking at. All right, now tangent will only, inverse tangent I should say, will only give me an answer from 0 down to negative pi over 2 That's a terrible looking half circle. 2 pi over 2. I'm going to try drawing that again. From negative pi over 2 to positive pi over 2, I will only get an answer in between there when I use my inverse tangent button. Whether I have tangent being equal to a positive number or a negative number, I'm going to start off with just finding the inverse tangent of that number. So here we go. First, the 2.5. I get a nice positive answer, 1.19. And just to, you don't have to know this, but the line that I draw, that I'm about to draw, will have a slope of 2.5. I'm not going to draw it accurately, but it's probably about like that-ish. A slope of 2.5. The angle I'm not getting, I got this angle. I'm not getting this angle, but I find it by adding pi. So pi plus the 1.19. Back over to the calculator. Come on, there we go. Pi plus 4.33. And these are two answers between 0 and 2 pi. And again, 2 pi is 6.28. Now for the second one, I'm going to again draw that I only get to work with angles between negative pi over 2 and positive pi over 2. That is what my calculator is going to give me. It's going to give me an angle in between there. So I'm going to look that, I'm going to put in negative, this time put in negative 11/5. And I get a negative angle, negative 1.14. Now, you don't have to be aware of it, but if I draw a line with a slope of negative 11/5, which I'm not going to be able to draw accurately, I'm just going to guess to draw it. My calculator gave me this negative angle. If I take that angle and I use the formula pi plus the answer my calculator gave me, actually I'll just do plus pi, then I get 1 point, actually I get pretty darn close to 2. So 1.997, I'm just going to write it as 1.997 to avoid confusion. It does round up to 2, depending if I use only 2 digits after the decimal point. So that gave me start again. This angle then is this one. But if I'm going to look at two positive answers that give me the answers to this equation when I do a first trip around a circle, then I'm going to take this negative number which put me here, and I'm going to add 2 pi to it to get its positive coterminal angle within a first round of a unit circle. And again, on the test, I'm going to avoid the issues of having the negative numbers, but I just want you to see them with the classwork and the homework. So 5.14. 5.14 and 1.997 are the two angles between 0 and 2 pi for that inverse trig function. Woo! Now realize that if you ever had the other three trig functions, you could reciprocate them and just do these as is. And so that means you know how to work with all six. And let me go over here. What was I meaning to say at that last bit? Oh, yeah, that's what I was saying with once you have two angles, take those two angles, add or subtract 2 pi any number of times, and you'll have every single possible solution to those equations. With tangent, you can simplify it to adding pi instead of adding 2 pi. Yeah.
So if it was like, for instance, cosine, it's add or subtract 2 pi, right?
Yeah, once you get the two answers with cosine, they're not going to be nice like tangent is, because the period of tangent has a period of only pi, but the sine and your cosine and secant and cosecant, those all have periods of 2 pi to get through. So those you have to be able to say two distinct angles and plus 2 pi for each one. But tangent, because it repeats its cycle twice during the normal amount of time, you can just find one number and put plus pi in, and you're good to go.
Thank you.
Yeah. And so this is a general explanation of, regardless of what trig function you're dealing with, if you can find those two spots on the circle, adding or subtracting 2 pi any number of times will find you everything. But if you understand that tangent and cotangent have periods of only pi, finding one is enough. But I'm trying to also keep this down to not throwing in too many exceptions to the rule, where you can just kind of follow a pattern with all of them that I'm showing you. So anyway, I'm going to end this recording, take a breath, and